Okay, and then for the combined problems, this can be a little bit trickier, and as you can see, it's a lot of steps, but as long as you follow these steps, you'll get the correct answer every time. So we're going to pretend first that the sample is 100 grams. So you're going to multiply every percentage given in your problem by 100 grams. The reason why this works is because all of these percentages are going to add up to 100. So you know that you've got 40% of whatever mass of sample you have. So 100 grams is just the easiest way to calculate. So in the problem, we're given that we have 40% carbon, 6.7% hydrogen, and 53.3% oxygen. So we're going to multiply these percentage values by 100 grams. And so we get that our sample is 40 grams of carbon, 6.7 grams of hydrogen, 53.3 grams of oxygen. Great. So now we need to convert from the grams to moles of each atom. So to do that, we just take the grams that we just calculated and we divide by the molar mass of our atom. So for example, for carbon, 40 grams we have, and then from the periodic table, we have 12.01 grams of carbon per mole of carbon, and dividing those, we get 3.33. And you do the same thing for hydrogen and oxygen, and we get that for hydrogen it's 6.63, and oxygen is 3.33. So now we divide each mole amount that we got by the smallest mole amount to get our ratio. So we take 3.33 because out of all three of these, 3.33 is the smallest mole amount that we calculated. And so we're going to divide each of these numbers by 3.33. So when we do that, we get 1 of carbon, 2 of hydrogen, and 1 of oxygen. And this right here, this just gives us our empirical formula. So we have 1 of carbon, 2 of hydrogen, 1 of oxygen. And you can just drop the 1 because that's it's implied if there's no subscript that there's a 1 there. Okay, so we got our empirical formula, and now we need to go to the molecular formula. So to do this, we did what we just did previously. So we find the molar mass of the empirical compound. So I've written out the calculation here. It's 30.03 grams per mole. And then we divide the compound molecular mass, which we were given as 180 grams per mole, by this molar mass of the empirical compound, which was 30.03 grams per mole. And when we do that, we get approximately 6. So what we do is we then multiply our empirical coefficients, our empirical subscripts, by this number to get the molecular formula. So C1 times 6 is 6, H2, 2 times 6 is 12, and O1 times 6 is 6.